Here are your solutions to review number 2. Again, as you should have done in review 1, please make sure you have tried all of these first, and then you're now going through and just making corrections. If you haven't done this yet, I recommend doing number 1, trying it, pausing the video, watching the solution number 1. Then try number 2. Pause the video to try number 2, and then restart it to get the solution, so on and so forth. Pause the video, try number 3, watch the video for solution number 3 if you haven't tried this yet. So if you don't do that, you're going to, again, make yourself think you know what you're doing, but you may not know what you're doing for the quiz tomorrow. So let's start with number 1 here. Which of the following statements is proven by the construction sketched below? So what is the construction showing? Okay, that construction is showing 2 parallel lines cut by a transversal, which pretty much all of these are saying, right? And it's showing corresponding angles. These angles here are corresponding, so that is choice A. If 2 parallel lines or 2 lines are cut by a transversal, form congruent corresponding angles, then the 2 lines are parallel. They are not alternate interior, right? They are not same side interior, okay? And through a point not on a given line, exactly one line can be drawn perpendicular. There's nothing perpendicular in there, okay? So it would be choice A. Number 2, in the given diagram, what type of line segment is PS? Well, as you could tell, they're saying that QS and SR are both 4, so that they're saying QS is equal to SR. That means that S is the midpoint. Okay, you have to take a look and examine the picture. S is the midpoint, and when you draw from the midpoint to the opposite vertex, that is known as a median. Okay, a median is midpoint to opposite vertex. Number 3, the incenter of a triangle is the point of concurrency of what lines? That's definition, that's in your notes. The incenter is formed by angle bisectors. If you want to do the incenter, you need the angle bisectors, so that's choice B. What would the perpendicular bisectors form? The perpendicular bisectors form the circumcenter. So I might ask you about that on the quiz. Write that down. Circumcenter is formed by the perpendicular bisectors. In the diagram below, triangle LMO is isosceles. They're telling us that. Okay, so LMO, this triangle right here, this triangle is isosceles. LO equals MO. LO equals MO. So it's an upside down isosceles triangle. That gives us information because if I have 2 equal sides, then the angles opposite those sides must also be equal. So 2 equal sides, the angles opposite must be equal. So I'm going to mark those equal. Boom, boom. See how the 2 equal sides, opposite angles? So if that's 55, this angle must be 55. Okay, and now I have a linear pair. Remember, you got to look for those 180s. See the 180? I'm going to change color. See the 180 here? All right, there's a linear pair. So 180 minus 55 is 25. 125. So this is 125 here. All right, and then the 3 angles of a triangle add up to 180. I have 125 and 28, right? So I have 125 plus 28, and that's 153. So what's left over for angle N? 180 minus 153, and that's going to give me 27. So angle N must be 27. Again, these 2 were 55. These 2 add up to 180, and then these 3, the 3 red ones, okay, these 3 inside this triangle here must add up to 180, so that's why it had to be 27. So choice D there. As shown in the diagram below, lines M and N are cut by a transversal P. So in order for lines M and N to be parallel, so in order for these to be parallel lines, because they didn't say they're parallel, but in order for them to be parallel and cut by a transversal, what do we know about angle 1 and angle 2? Well, they are not equal. Okay, see how small angle 1 is and see how big angle 2 is? Angle 1 would equal this angle, see? So angle 1 let me call this angle 3. Okay. Angle 1 would equal angle 3. They're alternate interior. And then angle 3 and angle 2 are supplementary. They add up to 180. So if 1 and 3 are the same, and 3 and 2 add up to 180, then 1 and 2 must also add up to 180. Okay, so again, 1 equals 3. I'm just going to write that down. Angle 1 equals angle 3. Okay, angle 3 plus angle 2 adds up to 180. So if I substitute angle 3 in for angle 1 plus angle 2 equals 180. All right, so I'm going to take my angle 1 and my angle 2. I'm going to add those together, 4x and 8x. 4x plus 8x is 12x. 14 and 10 is 24, and that equals 180. Again, you add them together right here. You add them together, and it equals 180. Subtract 24, 12x equals 180 minus 24, 156, and then divide by 12, and x equals 13. Okay, so x equals 13. That would be choice A. What is the value of x that makes L1 parallel to L2? So in this case, in order to be parallel, I'm looking at these two angles, and these would be alternate interior. If you have alternate interior, they must be equal to each other. So it's 3x minus 15 equals 2x plus 10. Subtract 2x, add 15. You solve this out, you should get 25. Okay. And value of x is 25, so that's choice C. A straight edge and a compass were used to create a construction below. So they did the construction for us instead of us, and they sometimes do this on part 1. They put constructions on part 1 as multiple choice. They give you the construction. They're asking you what is true, what is false. In this case, they're saying what is false. So you should be able to tell that this is an angle bisector construction. An angle bisector construction. Okay, you should just be able to tell by looking at it. They connected the two rays and then made the arcs here, and then we connected to that point in between those arcs, and that's how you do an angle bisector. So which statement is false? All right, well, let's see. 2 times DBC, DBC is this angle, is equal to ABC. So 2 times DBC, 2 of these, is equal to ABC. ABC is the big one. So would 2 of these equal 1 of these? Does 2 of these equal 1 of these? Yes, it does, because if I double that, I get that, right? And 2 of those does equal that. So that's a true statement, so that is not false. How about angle ABD? ABD, that's this angle right here. Does that equal DBC? DBC? Are these angles equal? Of course they are, because it's an angle bisector. This cuts the big angle. It cuts the big angle into 2 equal angles. So this is the definition of an angle bisector. So therefore, that is not false. That is true. So this is true. This is true. Half of ABC, half of ABC, half of ABC is ABD. ABD. Yes, it is. That is half of the big one. So that's also true. So this must be my false one. And they're saying 2 ABC, 2 times ABC, 2 times ABC, that's ABC. 2 of those is going to equal nothing in our diagram. 2 of those is going to be like, boom, that big, right? So that's not going to equal CBD, all right? So that's certainly going to be false right there. All right, so there's my false statement, and that's what I wanted. I wanted false, so that is D. All right, which diagram represents a correct construction of equilateral triangle ABC? You just got to know how to get your equilateral there, and it certainly B and D would not be right. There's no proof that you measured anything. Choice D doesn't even look right? But it's choice C would be the correct answer, because choice C, that's showing the arc right here. That's showing the measurement from A to B, and it's showing that it was copied here and here. So they put their compass on A, they put a little arc here, and you could even do the whole circle, right? We talked about that. It doesn't matter if it's the arc or the whole circle. Then they kept that length, and copied it from B and copied it from A. And that made point C. So that is what you should have. You should have 3 arcs for an equilateral triangle. All right, 2 more here, and then we're going to get to the constructions. In the accompanying diagram, so we have a lot of information here. FDE is 25. That was given right there. DFE is 130. That was labeled right there. And angle ABD is X. Okay, so what do we know? All right, what are we trying to find? We're trying to find the value of X. All right, so I know that I have, if I can do something here first, I know that this is 130. Okay, so if this is 130, I know this is 50. All right, that's 130, that's 50. So that's important to know. All right, so that adds up to 180, so I know that was 50. Now this is showing a 90 there. So see this triangle right here? See this triangle BDF? Triangle BDF adds up to 180. So 90 and 50 is 140. So what's left over? 40. All right, so 40 and 50 and 90, see that? 40, 50, and 90 makes a 180. So that triangle adds up to 180. Now, I know that, so now what I'm going to do is I'm going to say, all right, I have parallel lines. So let me make sure I know what's going on here. So I'm going to get rid of all this, and I just want to leave the 40 for now because I want to show you something. I have parallel lines, and there's more than one way to do this. Parallel lines. Okay, parallel lines cut by a transversal. See my transversal? Okay. So I'm drawing my auxiliary lines here. I have alternate interior angles. What is X alternate interior with? X and this. See? That and that are alternate interior. So X is going to be equal to the addition of 40 and 25. Okay? The total of this angle, that's 40, and that little one's 25. So that total angle right there is 65, and that's what angle X is going to equal because they're alternate interior. Okay, so X is 65 degrees. In the diagram below, X and Y, okay, so we're trying to find EAB, if measure of angle EAB is 75, so that is angle Y, that is 75 right there. Find CBD, so find X. Basically, they're telling you Y is 75, find X, okay? So actually, this one's pretty simple. We have parallel lines because it was given right here. Parallel lines cut by a transversal. I'm going to make my auxiliary lines. Okay, if this is 75, if this is 75 right here, then this guy must be 75, alternate interior. Okay, so there's alternate interior. You could also do it with corresponding angles. This is also 75. Okay, corresponding angles, 75. The vertical angles are equal. Okay, so this is 75, and this is 75, and then of course you got your 180. Boom, 180. So this must be 105. 105 and 75 gives you the 180. So measure of angle CBD, that's this guy right here, angle X. Angle X is 105 degrees. All right, now we'll move on to our constructions. And I have these on separate pages just so I can make it a little larger for you. So I didn't give you a lot of room. Hopefully you were able to do these and just check them over real quick here. So an altitude, for an altitude we are going to do a perpendicular to the line. Now we want to do perpendicular to QR. Perpendicular to QR. An altitude is just a perpendicular line. It's got to be perpendicular to. So we're going to do something that looks like this. See my little cursor? Our line should go right through here, but it's got to be perpendicular, all right, through P. So we're going to start with point P, okay, and we're going to make our arc. Open up our compass here. We're going to make sure we hit the line twice. Oops. Make sure we hit the, we got to hit twice. We got to open it up more than that. Okay, so let's see. There we go. And we missed it a little bit. So we're just going to make sure we extend that a little bit. if you miss it, you can always extend it with a straight edge. Okay, so we made 2 points. There's one right there and one right there. So 2 points right on QR. And then from there, we're going to make arcs out here. Make an arc there. And right there. Oh, maybe not. There we go. Okay, and from that point, so we basically did a perpendicular. We're going to connect those with our straight edge. Okay, line those up nice. And connect. Oh, with a hopefully, sometimes this ruler isn't giving me the proper man, see, it's not actually doing anything. Let me click on the ruler. Does that help? That might help. So from P, there we go. Connect right through. Of course, I got rid of my side there. I shouldn't have done that anyways. So there it is. So it should be right through. We lined it up right there, and then we go right through, and that makes a perpendicular right there. So that's what you should look like for number 12. Of course, you wouldn't have erased yours. All right, number 13. Okay, so a median. Median's very simple. You just need to do the perpendicular bisector because we got to find the midpoint. We got to find the midpoint of AB. So we're going to go compass on A. We're going to switch colors to blue here. We're going to open up our compass more than halfway, right? Boom, boom. Okay, go to B, flip it around. Boom. And we just turn our ruler here. If you line up those points right there, you don't even have to draw it. You could just mark the midpoint right there. Ooh. Don't do that. Leave that arc where it was. I'll undo that. Put it back where it was. Redo. Okay. There we go. And then just draw from the midpoint, connect it to the opposite vertex. So again, a median is a line drawn from the midpoint of a segment to the opposite vertex. I'm going to line that up right there, and we are going to draw from C right there. My straight edge is not working good today. So that should be a straight line. My virtual straight edge here is not working well. All right, 14, construct a parallel line through A. If the point's off of the line, you want to make a parallel, just do 2 perpendiculars. So we're going to go perpendicular through A, and then another perpendicular through A. 2 perpendiculars guarantees that you have parallel. All right, so we're going to take our compass, we're going to put it on A, change colors again. Let's go to, let's do purple now. All right, let's swing this around here, open up that compass a little bit, make sure we hit, oh, we're not going to hit, undo that. Open up our compass a little more, make sure we hit the line twice, there we go. And from those points we just created, we're going to make sure we hit, we're going to make an arc out here and flip it around, put our compass on point C, and another arc. Okay, so from that point right there, that point we created right there, okay, we're going to connect that to point A. Hopefully our straight edge works here. It worked that time. All right. And I'm actually going to go extend it even longer because we want to make sure that we are able to do another now we're going to go perpendicular the other way. So this line we just made right there, right? Now we're going to go perpendicular through A the other way. So now we're going to put our compass on A. Put our compass on A, shorten it up a little bit. Okay, and put an arc here. Flip it around and mark, oh, what are we doing here? Right there. Okay, so you got your arcs on either side of A, and then from point A, or I'm sorry, from those points we just made, I'm going to mark those for you. One right here, one right here. From there, put your compass point on those points, open up the arc, and make an arc down here, and then make the exact same arc intersecting that right there. And then you could even go further. You can go the other side from the other point there. You can go the other way. Okay, you can go both sides. It's just a little bit more accurate. So see this point right here and this point right here? You line those points up with your compass, with your straight edge. Line those points right up with your straight edge. Keep grabbing the wrong thing. And that makes, hopefully it draws it correctly. There we go. That makes a parallel line to the original line. So we did a perpendicular and then another perpendicular. It looks like it's off a little bit just because my compass moved a little bit. But anyways, that's what you do. Perpendicular, perpendicular, and that makes the purple line I just drew parallel to the original BC. So we constructed a parallel line. All right, a couple more here. To do a rectangle, all right, so we're going to make an original line here. All right, and we're going to copy the length of D. We're going to copy length D. I'm going to have to move these over a little bit, actually. Oh, I can't. It's to unlock, allow vertical move. Okay, there we go. So I'm going to copy these lengths. Boom and boom. Okay, so right there, that's how I know I copied. All right, I'm going to mark one of the lengths here. I'm just going to put it right there. There's a point right there. And then I'm going to copy that length onto my line. So I know I already have 2 points of my rectangle. I have 1 point there and I have 1 point right there. So 2 points given. Okay. Going to move these guys out of the way right now. Okay. So now what you need is, to get a rectangle, you need perpendicular lines. So I'm going to copy the distance here. Let's copy this distance. Oh. Okay. Copy that distance right there. And go boom. And then flip it around and go boom. Now, notice how on what I did before is I just extended the line a little bit. So I'm going to make this a little longer. Remember, you want to go on each side of the points you created. Okay, so that's not very good, right? Our ruler's not working again. Come on, ruler. There we go. All right, so we just extended our line. And then from those points we just created, we're going to swing an arc. Open up our compass. Okay, we're going to swing an arc up here. And then we're going to swing another arc. From the other point we created, we're going to swing an arc up there. So I know now that I've created a I know it's perpendicular. It's perpendicular. Now I can connect right down there. Okay, and now we're going to do it again. Okay, I'm going to get rid of this point right there just to so we don't have confusion. Don't erase yours. Okay, so from right here We need an arc on both sides. There's one. And I'm just going to go the other way around like that. That's good enough. So I have 2 points. 1, 2. And from those points, I'm going to make arcs above again. Compass there. Open it up. Boom. There we go. And then from the other point, there we go. All right. So, of course, that doesn't look correct, does it? Doesn't look like I did it right. That's right there. That, I think that one's off a little bit. Nope, that one is that. Okay. Just doesn't look right. Doesn't look like it's going to be perpendicular, does it? Yeah, it's off. That's definitely off. So something happened here. I must have moved my compass. Let me try this again. So from this point, we're going to go boom, make a circle. Yeah, see, it's off. That circle right there is not going to do any good for us. So this right here, that one is going to be gone. Let me get rid of this. Yeah, we don't care about that one. Okay, so there we go. We're going to use this point and this point. There we go. And we're going to get rid of these because that's messed up as well. Right there, that's messed up. And right there. Okay, so now we're ready. Open up our compass. Again, we just want to make we're just doing perpendicular here. Perpendicular lines. That looks better. Alright, so right there, line me up with my straight edge. And we're off. We're still off a little bit. So this tool here is just not working very well today. Let's pretend we're on, okay? There we go. So now we need to know that we need the length of C. Okay, we need the length of C. So we're going to copy, oh my goodness, right there. We're going to copy the length of C right there. Open it up. There's my length of C. So right now I have length of C. I'm going to put it on my vertex and I'm going to swing my arc there and then go to my other vertex and swing my arc there. So there are my 4 points for my rectangle. I'm going to do them in a different color. I have 1 point here, I have 1 point here, I have 1 point here, and I have 1 point here. How do I know it's a rectangle? Because I know I made perpendicular lines, so I know I have 90-degree angles, and I copied those line segment lengths. Okay, so now all I have to do is connect my blues, and I am done. And then I only have one more to do, and I know this video is long, but it is important that we get all this information down. And of course, we're not working again. Come on. This is so annoying. Alright, so with your straight edge, mine isn't working right. You connect those and you have your rectangle. Hopefully it looks better than mine. And the incenter. The incenter is 3 angle bisectors. Okay, so we're just going to bisect each angle, and this should go pretty quick here. You can open it up however long you want. You're going to make your arc, then you're going to go to those 2 points and you're going to open it up and you're going to make arcs that intersect each other. See that point of intersection right there? Boom. Connect that to A. Alright. Again, this should already be done. Let's see if our ruler works here. Is it going to work? Nope, not going to work. Okay, guys, I've had it. The ruler's not working. I feel like I'm done on this video. Can't get it working. So there's one that's supposed to be a straight edge there, but it's not. Alright, and then you're going to do 2 more angle bisectors, right? You're going to have one that comes right through the middle there, and then you're going to have one that cuts right through B, and they all intersect at one point, and that one point is called the incenter. I just can't handle it anymore. Hopefully you did it already and you're just checking it over. Again, 3 angle bisectors intersect, and that makes the incenter. Also, a circumcenter is 3 perpendicular bisectors, so make sure you study your vocabulary, and good luck on your quiz tomorrow.